Hey guys, welcome to my video. Today we are going to discuss condition for 4 points to be concyclic. So in this concept, I will be discussing 3 ways to write the condition and derive them. And I will also be telling you how this condition can be applied in mains level question as well as advanced level questions. So stay tuned with me till the end of the video. And if you feel the content is useful, please share it with your friends. And also don't forget to subscribe to my channel. So let's learn the topic. Condition for 4 points to be concyclic. Today we are going to discuss this topic. So before to this, I would like to revise one standard property which is already been learned by you in 9th or 10th standard. That is, if there is a circle and there is a tangent drawn to the circle from a point outside, let's say from P, the tangent is drawn, and also from P, a secant is also drawn to the circle. So the property is, if such a scenario exists, then we have PT square is equal to PA into PP. This is a well-known property. So now we are going to use this concepts only for deriving the condition for 4 points to be concyclic in coordinate geometry. So let's start with that condition. So I will be taking two lines here. Let's say the line equation 1. L1 is the equation of the line 1, which I'll take it as a1x plus b1y plus c1 is equal to 0. L2 is another line, a2x plus b2y plus c2 is equal to 0. Let's say I'm drawing the coordinate system here, and then also I'm plotting these two lines. So they will have certain x and y intercepts. Based on the numbers what you have in the line, you can draw the lines. Suppose, let's say these are the 4 lines which I'm drawing here. Let us assume there exists a circle which passes through these 4 points and denote that points to be O, A, B, C, D. Suppose if I draw a circle which passes through all these 4 points, so from O we can draw a tangent OT1 to the circle. OT1 and OT2, because there will be two tangents drawn to the circle. So according to the previous property, I can write OT1 square. Like suppose if I'm denoting the tangent somewhere here and it is meeting at T1, and let's say OT2 is a tangent here which is meeting at T2. So OT1 square will be equal to OA into OB here, and OT2 square is equal to OC into OD. But length of the tangents drawn from a point to circles are same. So OT1 square should be equal to OT2 square, which implies OA into OB is equal to OC into OD. So this is the initial condition, when points are clear to you, you can take out these distances and then prove that the points are concentric. But further, if we explore more on this concept, let us take here the A coordinates. The point A, we can write it as minus C1 by A1, comma 0. Point B, we can write it as minus C2 by A2, comma 0. The point C, we can write it as 0, comma minus C1 by B1. Point D, we can write it as 0, comma minus C2 by B2. So according to the condition which we derive, OA into OB is equal to OC into OD. So we can write the distances as C1 by A1 into C2 by A2 is equal to C1 by B1 into C2 by B2. So this can be written as A1 A2 is equal to B1 B2. So this is another way to express the condition. Like the moment we know the straight line coefficient of x and coefficient of y, so directly we can use this as a condition. And from here, if we rearrange the equation, let's say A1 A2 is equal to B1 B2, or you can also write A1 by B1 into A2 by B2 is equal to 1 and introduce a minus sign. So this denotes the slope of the first line and this denotes the slope of the second line. Suppose if L1 slope is M1, L2 slope is M2, from this condition, we get M1, M2 is equal to 1. So this is the third condition for concyclic points formed by two lines whose slopes are M1 and M2. So if there are two lines, let's say I'm taking an example here. If two lines are there, which is 3x minus 4y plus 10 is equal to 0, and 4x plus ky plus 7 is equal to 0. Now, if these two lines cut x-axis and y-axis at 4 points, what is the value of k plus 2? So, this case, you already knew the condition for both lines. Coefficients are very much clear. A1, A2 is equal to B1, B2. So directly we can pick the values of A1, A2 from here. So which is 3 into 4 and that this is equal to. So since it's a modulus distances and we can take it in the form of 4k. So k will come out as 3. So answer for k plus 2 will be 5. So isn't it simple when you know the standard result already to apply it for an MCQ, or it can be fill in the blank or numerical based question. So directly these results can be used in solving a mains level question. Now let's see how this concept can be used in constructing an advanced question. Let ABC be an isosceles triangle with AB is equal to AC is equal to 6 units, and let D be the point midpoint of AC. A circle through D touches AB at B. If OC is equal to 2, then the radius of circle is equal to. So now this is a question on which we'll be using the concyclic condition. So initially, let me draw the figure here. So there is a triangle. There is a circle which passes through the midpoint of AC and also through B. Let's say this is A, B, C. Let the midpoint of this be D. Now we have to draw a circle which passes through D as well as touches the line AB at P. So this is a circle. A circle through D touches AB at B. If OC is given as O is the center of the circle, OC is equal to 2, then the radius of the circle is equal to. So in order to solve this question, let us extend this AC to meet the circle at E. And OC is extended to meet the circle at H. H on one side, and it is extended to meet the circle at F on the other side. Now look at this point C. Even if the point is outside or inside, the same condition is going to hold good. This is the center O. Now from the property, we can write it as AD into AE is equal to AB square. This is a condition which we have used, like PT square is equal to PA into PB, what we learned in the beginning, that property. And if you're using this property, like we can write down what is AD given here. Since it's a midpoint, it is 3 times. And AE we don't know, so but we can write it as 6 plus CE. Because AC is given as 6. CE we are just writing it as it is. And AB square is nothing but 6 square. So from this we can find out the CE as 6. Now the same property can be applied here. At C, if you look at CD into CE is equal to CF into CH. So the point need not be outside, even if the point is inside the circle, and we have the conditions like AB here, CD here. So we can also write PA into PB is equal to PC into PD. This is also a property learned it in lower classes. So on-cyclic condition only. So we already know what is CD. That is the midpoint. So we have 3. CE we found it earlier, which is 6. CF and CH. We know the distance of OC is 2. If we are assuming this total distance is R, CH would be, sorry, this is CH. CH would be R minus 2 and CF would be R plus 2. So from this, you simplify and solve for R, that will give you root 22. So I hope this explanation is clear to you, and it's a very interesting way of applying the learned concept of concyclic condition. So let's see another example. This is also an advanced question. From a point P, two tangents are drawn. To the ellipse, x square by a square plus y square by b square is equal to 1. If these tangents intersect, coordinate axis, at concyclic points, find the locus of the point P. So we have learned another condition that M1, M2 will be equal to 1 if the lines intersect the coordinate axis at 4 points and they're concyclic. So we are going to use that condition. Let's say we are taking an ellipse here and we are drawing the pair of tangents. This from the point H comma K. So we are finding the locus of this P now. General tangent to ellipse is y is equal to mx plus square root of a square m square minus b square. A square m square plus b square. So now we will allow this tangent to pass through H comma K. So this gives us a quadratic equation in M. K minus mh whole square is equal to a square m square plus b square. And now these tangents are intersecting the coordinate axis at 4 points. So the condition what we have is m1, m2 is equal to minus. So in this quadratic equation in M, we can take the product of the slopes and equate it to 1. So before that, we will rearrange the equation here. The equation with coefficients as m square is h square minus a square into m square plus or minus 2hkm plus k square minus b square is equal to 0. So if this has the roots m1 and m2, we know that the product of the roots is 1, but product of the roots from the equation is k square minus b square by h square minus a square is equal to 1. So rearrange this equation, h square minus a square is equal to k square minus b square. So we will be getting an hyperbola here, a square minus b square. So the locus can be written as x square minus y square is equal to a square minus b square. So assuming these two tangents are intersecting the coordinate axis at 4 points, which are concyclic, we directly apply this condition. I hope the explanation is clear to you. But for all this to understand, you need to have a knowledge about an ellipse and the tangents equation. But concyclic condition is a beautiful application. So I'll be coming up with more such interesting concepts. Bye for now.